The topic of this video is graphing piecewise-defined functions. Alright, let's go ahead and solve this problem. We have g of x equals x if x is not 0, and negative 2 if it is. Okay, so the first thing you want to recognize is this is an equality. X equals number. So this will contribute just a single dot to the overall picture. This is therefore not an equality, that makes it an inequality, and this is something that we are going to have to cut. The other thing that we want to pay attention to is g of x equals x is the identity function. So this should be very quick and easy to graph. Let's begin. All right, let's go through the steps together. Step 1, create a complete graph for each piece whose if condition is an inequality. That's our top line, g of x equals x, the identity function. All right, so you should be able to create the graph of the identity function at the same speed that I can. You should know exactly what x's to use, and you should know exactly what y's to use. The identity function is the one where all the x's and y's match. So we get points on it like negative 2, negative 1, negative 1, 0, 0, 1, 1, and 2, 2. It's a straight line through the origin with a slope of 1, and as such, it requires a straight edge to draw it. So we draw this line with a straight edge. Now, this is a domain-restricted function, which means we're not going to use the entire line. We are now going to cut it. So, where do we cut? Well, after the word if, any number is a place where you cut. So we have to cut at 0. So find 0 on the x number line and cut vertically through it, which means we're cutting our graph right through the origin. Now, which part do we keep? Well, we keep the part where x is not 0. Anything to the left of 0 is not 0, so we keep it. Anything to the right of 0 is not 0, so we keep that too. In fact, the only thing we are not going to keep is 0 itself, and here's the reason why. When we get to the part where we put open or closed dots where the curve meets the cut, we recognize that the not equal symbol is an open dot. That means we need an open dot at 0 where the blue curve meets the red cut. So that right there is now a point from our line that is missing. We have all points of the line that are to the lower left of that open dot, all points of the line that are to the upper right of that open dot, but that open dot now represents a missing point. Okay, that was the top piece. Now we're ready for the bottom piece, which is the easy one. Notice that it is of the special form, g of x equals number if x equals number. G of x is the same thing as y. So what this is really saying is y equals negative 2, x equals 0, which gives us the ordered pair 0, negative 2. So we graph the point 0, negative 2 on our graph, and that would be right here. It's a closed dot because of the inequality symbol, which is equals. Okay, we did it. We created our graph. This is the final answer as far as the graphing part of this problem is concerned. Now we just have to move on to the rest. Okay, is this continuous? Can you draw the entire blue part of the graph without picking up your marker? And the answer is no. I can get all the way to here, then I have to pick up my marker and put this closed dot here, then I have to come back and continue the rest of my journey. And for that reason, this graph is not continuous. All right, how about the domain? Well, domain is most easily seen by looking after the word if in our function definition. So the top represents all the numbers that are not 0, and the bottom represents 0 itself. And if you think about it, every number in the world is either 0 or not 0. So if we put these together, this comprises all real numbers. My domain is negative infinity to infinity. And now the range. The range will be done by looking at the graph. We need to find the point that is furthest down. That would be this point right here represented by the arrowhead. Then we need to find the point that is furthest up. That would be the point right here represented by this arrowhead. Can we get from the bottom to the top by moving along our graph without picking up our marker? The answer is no, because we have to go through a hole. The hole means you have to jump over the hole and then keep going. So this graph represents all possible y values from the lowest, which would be negative infinity, to the highest, which would be infinity. But we have to remove the open dot here. We have to remove the 0. And so what that means is we're going to go from negative infinity all the way to 0, and then skip over 0, and then go from 0 the rest of the way to infinity. And we'll have parentheses in all of these places. This comprises our range. Now, the most common question I get from students about this particular problem is, why does 0 have to be removed from the range, but not from the domain? So let's see if we can think about that. I hope we all agree that this particular open dot, 0, 0, represents a missing number. The domain is missing a 0 because of this open dot. The range is missing a 0 because of this open dot. So the reason why the domain is still all real numbers is because there's another part of the graph which helps us fill in that missing information. This point right here is 0, -2. Wow, could have been more wrong on that. This is 0, -2. And for that reason, we do have a point on our graph with an x coordinate of 0. So even though this hole in the domain for the missing value of 0 represents a gap, this point with an x of 0 fills that gap, and that's why we have all real numbers for the domain. We do not, however, have a filling in of the gap for the range because range measures y values. This -2 is not providing the missing value from the range of 0. It's just an additional -2 that we already have from this point over here. It's duplicated. And so for that reason, the range has a missing 0 and the domain does not.